Hello everyone, let us see next example of this chapter. Earlier we have seen this 12th example and the answer for this example was m is equal to -1. Okay, let us see now next example. This is homework for you. Show that this function is given f of z is equal to numerator is 2xy into bracket x plus iy and divided by x square plus y square if z not equal to 0 obviously, and f of z is equal to 0 if z is equal to 0 means what? If we put z is equal to 0 here, we get f of 0 is equal to 0 is the given thing. Okay, meaning of this 2 is f of 0 is equal to 0 if z is equal to not equal to 0. This is given thing, and we have to what? We have to show that this function satisfies CR equation at origin. Okay, we have CR equation particular at a particular point origin. We have to follow this example or this formula. Okay, refer this example. The example is same like this, the function is only different, and you have to calculate these derivatives, w by w x, w u by w y, w v by w x, and w v by w y. This is the derivative at origin. Okay, these have different definitions. Then we have to show that this function satisfies CR equation at origin, but f dash z doesn't exist at origin. Means what? We have to find out f dash z at origin means z is equal to 0. At origin means x is equal to 0, y is equal to 0. That means z is equal to x plus iy, that is 0. At z is equal to 0 means f dash 0. Here we have to find out f dash 0, and we have to show that f dash 0 does not exist like this. Okay, follow these steps, and this is the homework for you. Refer example number 11 for this. Now let us see next example, 14th example. If fz is equal to fz is analytic function, the fz is given analytic function, that's why it must satisfy CR equation. Now we have to show that this equation we have to prove. What is this equation? This is one bracket square plus other bracket square is equal to mod of f dash z mod complete bracket square or mod f dash z square. That means we have to solve the LHS side, and we have to prove that this is equal to this term. Now depend on the LHS side, we have to find out first derivative of this term, that is mod of f of z. Here also mod of f of z is there. Its derivative with respect to x, then its derivative with respect to y, and take this LHS, and we have to prove that this is equal to this. Okay, let us start with the function. Let f of z is the analytic function. Analytic means it must satisfy CR equation, and f of z, let f of z is equal to u plus iv. This is our basic assumption. Now we have to find out mod, that's why take mod of both side. We get mod of f of z is equal to mod of u plus iv is equal to, we know at the beginning of this chapter what do you mean by modulus of any complex number z. If z is equal to x plus iy, okay, then mod of this number is nothing but square root of real number square plus imaginary number, that is coefficient of I, its square. Okay, that's why I use this definition here. Mod of f of z is nothing but under root of this real number square plus this imaginary number, imaginary part, v square. Okay, now we get this. Now we have to take derivative of this term, okay, with respect to first x and then its bracket square. First take derivative with respect to x. For that we have to use chain rule. Okay, let us see how we can solve that. Dava of dava x then mean derivative of mod of f of z. That means dava of dava x mod of f of z is under root of u square plus v square, that is equal to u square plus v square raised to half. Now it is the u and v are functions of x and y. Okay, and we have to take derivative with respect to x. That's why you have to use chain rule here. First we have to take derivative of this term, then we have to multiply derivative of this bracket with respect to x. Okay, because it consists u and v, not x and y, right? That's why using chain rule method, like for example, what is derivative of sine 2x? How we calculate that? What is derivative of sine 2x? Because for that, to find out derivative of sine 2x, we apply the derivative of sine x first to this function. What is derivative of sine? It is cos 2x, and we have to multiply the other derivative. Which derivative is that? The extra term here, 2x. Derivative should be multiplied. This is called chain rule of derivative. Similarly, here also, u square plus v square raised to half derivative we have to first find out. What is that? Half x raised to n derivative should be applied here. What is x raised to n derivative? N into x raised to n minus 1. That's why a derivative of this first is half into this bracket raised to half minus 1. Half minus 1 is minus half. Okay, but and into, by chain rule we have to multiply derivative of this bracket further. What is derivative of this bracket? Derivative of u square plus derivative of v square. Again, derivative of u square is x raised to n derivative should be applied. 2 into u. Again, u derivative by chain rule we have to multiply u x. Suffix means derivative. This is a short form of derivative. Dava u by dava x, nothing but u x. Both are same. Okay, this is just a notation. Therefore, 2u, derivative of u square is 2u into derivative of u multiply, that is u with respect to x, plus derivative of v square, similarly 2v into v derivative is vx. This is very important step. Okay, this is called chain rule of derivatives. Now to take, we have to just simplify now. Take 2 common, cancel with this 2, we get u square u ux numerator plus v vx divided by this minus half turns goes to the denominator, it becomes plus half, u square plus v square raised to plus half. Okay, now similarly calculate the derivative of this term with respect to y. You can write down directly what is the difference between this and this. What will be the difference? Only suffix should be y. Rest of the terms are same because it is a u square plus v square is a symmetric function. Okay, both are u and v terms are similar. That's why derivative we can write as similarly we can write down. Therefore, you can solve it like this. Okay, now once we get these two derivatives, okay, take now LHS side. Consider LHS side. This square plus this square. This square means this number square plus this number square here. Okay, now denominator is u square plus v square half. U square plus v square half is square. Half and square gets cancelled. Both the denominator take u square plus v square common outside. Now in the bracket we get this term square plus this term square. Okay, now we have to use CR equation here. What are the CR equation? Cauchy-Riemann equation. Why we are using? Because Z is analytic is given. Okay, that's why CR equation are ux is equal to vy, uy is equal to minus vx. Now put here vx value as minus uy. Okay, and uvy value as ux. Rest of the terms keep that as it is. Okay, what we are going to do, just here vx and vy we have to replace by using CR equation. Uy minus uy and ux. Okay, this is why CR equation. Now it is one bracket square, this is other bracket square. Expand by using a minus b bracket square. A square u square ux square plus b square v square uy square minus 2ab, that is this term, plus. Now again a plus b bracket square, expand like this. Now these two terms gets cancelled. Okay, and remaining from these two terms, take u square common, bracket contain ux square plus uy square, plus from these two terms v square gets common and uy square, here ux square, first ux square plus this uy square. Now again from these two terms this bracket is common. Ux square plus uy square is common. Bracket consists, remaining bracket is u square plus v square. Now this u square plus v square, this u square plus v square gets cancelled. Final answer is ux square plus uy square. Okay. Now write down this note first. If f of z is equal to u plus iv, then f dash z is nothing but ux square plus vx square. Okay, write down this term as a note and mug up this. F dash z is nothing but ux square plus vx square. Okay, that's why we write down as this. Now take mod of this f dash z, because this we get LHS side. Now our RHS side we have to show that this. That's why we are calculating this. F dash z is ux square plus vx square. Now its mod is nothing but under root. Again we know, again this should be I. Okay, ux square plus I is as it is vx square. Now take mod of this term. Mod of this term is nothing but under root of a real number square plus this imaginary number square. Okay, it must be like this. Okay, write down this note as if f of z is equal to u plus iv, f dash z is ux, is not square, its square is here, ux plus ivx. Okay, derivative with respect to x. Now take mod of f dash, this mod of f dash z is nothing but under root of real number square, real part square plus imaginary part square. Okay, now squaring both sides we get here. Then from equation number, call this as 1, we get this LHS is equal to ux square plus uy square. Now again using CR equation, uy is equal to minus vx. These are derivatives. Put this value uy is equal to minus vx here, and minus square is plus square, ux square plus vx square. And what is ux square plus vx square? We have calculated its mod of its square, taking square on both sides. Okay, this is our RHS side. Hence proof. Okay, now next example, let us consider 15th example. Before that, take one note. If f of z is equal to u plus iv is analytic, then u and v are orthogonal to each other. Okay, now what do you mean by orthogonal? See, orthogonal, suppose we if we start from lines, two lines are orthogonal, means these two lines must intersect each other to 90 degree. That means like x and y axis are orthogonal to each other. These are according to the logic to the lines. But if u and v are not lines, these are surfaces. Okay, these surfaces are orthogonal, means suppose this is x and y axis, and suppose this is z axis. Okay, x, y and z, and suppose this is one surface, right? It is in three-dimensional space. Okay, and suppose this is other surface. Okay, it is again in the three-dimensional space, and suppose these two surfaces cut each other at a particular point. Suppose this is a line, okay, where these two surfaces intersect with each other. And if you find out the angle between this line and the tangent on this surface, suppose this is the tangent on the surface, you have to imagine that, because it is in three-dimensional space, and suppose this is angle is 90 degree. Okay, then two surfaces cut each other at 90 degree, then such surfaces are called orthogonal surface. Ortho means 90 degree. Okay. Now what is our theory? If f of z is analytical function, then u and v are orthogonal functions. It is a theoretical proof. Now let us see next example. Depend on this theory. Find the orthogonal trajectories of the family of the curve. Orthogonal curve, meaning of curve and trajectories are the nothing but curves. Orthogonal curves means orthogonal trajectory. This is a synonym word for curve. Okay. Find the orthogonal trajectories of the family of curves, that is x cube y minus xy cube is equal to c. Okay. Now this is one given curve. We have to find out like this. These are two curves. One curve is u, other curve is v. One curve is given. Suppose that is u. Let u is equal to x cube y minus xy cube. Take c on this side, we get is equal. You can skip this c, because if you take derivative of u, c becomes a 0. Derivative of constant becomes 0. That's why you don't need to write c here. Okay. Suppose u is equal to x cube y minus xy cube is equal to c is first curve, that is u. We have to find out v, other curve. Okay. Let us start. And suppose v is equal to c, this we have to find is the family of curve which are orthogonal to each other. That means which is same. And v is equal to c is the family of curve which is orthogonal to u. Okay, these are two curves of f of z. The function f of z is analytic. Okay, then u and v forms orthogonal system or orthogonal to each other. This is our theory. Where f of z, this is our assumption, u plus iv. That means ultimately what is given and what we have to find, f z is equal to u plus iv is a function, is analytic, u is given, one curve is given, and we have to find out the orthogonal trajectories, means orthogonal curve to the u. That means we have to find other curve v. Of course they are orthogonal because this is our theory. If f z is analytical, then u and v are orthogonal. Okay, same example but in different words. Okay, like earlier we have to find out v, u is given. Let us start. Now we have to use derivatives first. We have to find out derivative of u with respect to x with respect to y. Dou u by dou x is x cube, only derivative of x is 3x square, y is constant, minus x derivative is 1, y cube is constant. Now u derivative with respect to y. Here y is there, y derivative is 1, x cube constant, minus y cube derivative 3, x as it is, y square. Okay, these are two derivatives. Now start with this. Now f z is analytical, that's why they satisfy CR equations. Ux is equal to Vy and Uy is equal to minus Vx. These are CR equations. Now start with this. Here W by dou x is this and W by dou x is this. That's why dou V by dou y is nothing but this term. Okay. Now you can skip this. Call this equation number 1. Integrating this equation with respect to y. Okay, what we get? Integration derivative gets cancelled. V is equal to derivative with integrating with respect to y. We get y square by 2 here. This is constant. Keep that as it is. It comes outside of the integration. Minus y cube derivative integration is y raised to 4 by 4. And here we are applying partial integration. That's why plus instead of c, because here two variables are there, x and y. Keeping while taking integration or derivative with respect to x, we keeping other variable constant. That's why while taking integration on both side of indefinite integral, we take c as a integration constant. Okay, when we are taking that integration constant c, when there is only one variable. Okay, but here in this case we have two variables. That's why the integration constant is not c here. It must be a function of opposite variable of this y, that is phi of x. Okay, remember this term because we have both x and y here. Okay, call this equation number 3. Now we use this equation, first equation of CR equation here. Now we have this second equation, okay, and already w by w y we have. We want w v by w x because our intention is to find out v. That's why, and we have this v, that's why now taking derivative of v with respect to x. Differentiate above equation with respect to x. What we get? W v by w x, keeping y obviously constant. What we get? X square derivative is 2x. That's why 3 2 is 6 x y square upon 2 minus, here it doesn't contain x, that's why derivative of this is 0. Derivative of this is 0, and derivative of phi of x with respect to x, we don't know phi of x, that's why it becomes phi dash of x. Okay, and this is w by w x, nothing but minus w by w y, and we have w by w y as this. It becomes minus of this, okay, in next step. That's why it becomes 3 to the 6. That's why it is the simplified form is 3xy square plus phi dash of x. Call that as 2. Then from 1 and 2, w by w x is here, okay. Already we have w v by w x as minus w by w y, that is minus of x cube minus minus plus 3xy square, okay. Now comparing w v by w x here and w v by w x here, okay, 3xy square is same. That means phi dash x is nothing but minus x cube. If these two are equal, LHS side, then RHS must be equal, and comparing these two we get phi dash of x is equal to a minus x cube, because these two are same, okay. Now we want phi dash of we have to calculate phi of x, because our answer is we have to find v is here, and phi of x is extra term, we have to find out from here. Now to cancel out derivative term, we have to integrating above equation with respect to x. Now here only one variable is there, that means while taking integration with respect to x, we get integration derivative gets cancelled. Phi of x is equal to minus x cube, integration is x raised to 4 by 4, and plus integration constant c we have to take, because it is normal integration with containing one variable, that's why here c. But while taking integration on both side of this equation, we have two variables x and y, that's why we have to take phi of x as a integration constant here. Now phi of x is this. Now putting this value phi of x in our answer v here in 3, we get v is equal to this term as it is, and phi of x as this. This is our answer. This is the other orthogonal curve, okay, like earlier example we have just solved. Now consider next example. If an electrostatic field in xy plane is given by the potential function phi is equal to 3x square y minus y cube, find the stream function. See, write down one note here. Before this example, write down this note. If f of z is equal to phi of I psi is called electrostatic field. In xy plane, obviously where phi and psi are functions of x and y, and f of z is called stream function. Sorry, not this f of z. This phi of given thing is xy plane potential. Okay, potential function is given. Okay, right. This phi is called potential function, and this psi is called stream function. Okay, this is the same example like a earlier example we have just solved, but words are only different. For fz is called the electrostatic field. If fz is electrostatic field, then if f of z is called electrostatic field, then this phi is called potential function and psi is called stream function. What is our question? In electrostatic field x and y in xy plane uh, is given by the potential function phi. Phi is given. We have to find out the stream function. That means we have to find psi. Instead of u and v, they have just replaced by phi and psi. Okay, understand that. Write down this note first before this example only. Okay, let us start the answer. Let f of z, starting with the f of z, is the analytical function. An electrostatic field is always an analytical function. Remember that. Okay, you can write down here also. Okay. And fz is analytic. Okay. Okay. Now let f of z is equal to phi plus I psi be the analytic function in xy plane. Then fz will be analytical function, and phi and psi are obviously the harmonic function. This is one more theory. So CR equation will be satisfied by the by f of z. What was the CR equation? What are our basic CR equation? Ux is equal to Vy. If f of z is equal to u plus iv, then CR equations are ux is equal to Vy and uy is equal to minus Vx. Instead of u and v, there are only phi and psi. That means dava u by dava x, that is dava phi by dava x is equal to dava psi by dava y here. And dava psi by dava y is equal to minus dava psi by dava x. Okay, where phi is a potential function which is given and psi is the stream function, that is we have to find out by using earlier method. That means u is given, we have to find v. Same questions all over, just they have used the different language and different words and different theories like electrostatic field and all. Now start with this dava phi by dava x first. Phi derivative with respect to x is 6xy. Derivative of y cube 0 obviously. Dava phi by dava y first 3x square minus 3y square. Okay, now form equation number 1. Compare this. Dava phi by dava x is 6xy, that's why this is equal to this. Dava psi by dava y is equal to 6sy. And now we have to use this equation. That's why we have to find psi here. Now integrating with respect to y, what we get? Psi is equal to integration of with respect to y. 6 is a constant. Y derivative integration is y square by 2 plus integration constant as a function that phi of opposite of y is x. 2 3 is 6, 6xy square plus phi of x is our psi. Now we have to find out phi of x. Now we have just used this equation. Now we are going to use second equation of CR equation. Now we have already psi, we want psi dava psi by dava x. Differentiate this equation with respect to x now. What we get? Dava psi by dava x is equal to, with respect to x derivative is 1, 3y square plus phi derivative is with respect to x is phi dash of x. Okay. Now call this equation number 2, this is equation number 3 and this is 1. Okay. Now dava psi by dava x from this equation is minus on that side, minus dava phi by dava y. That's why it becomes dava psi by dava x is equal to minus dava phi by dava y, and dava phi by dava y is this here. Put this value here with opposite side, opposite sign. we get this equal to del psi by del x, and we have one more del psi by del x. LHS are same of these two equations, that's why RHS must be same. That's why comparing from 2 and 3 or 3 and 4. Okay, this is 3 and 4. These two equation 3 and 4. What we get? 3y square is same. That's why phi dash of x must be equal to minus 3x square. Now we want phi of x. That's why integrating. To cancel the derivative effect, we have to integrate both sides. With respect to, obviously, there is only one variable x. That's why we get derivative integration gets here with respect to x. We get phi of x is equal to x square derivative is 2x. That is minus, sorry, integration x cube by 3 plus integration constant we have to take c, because it is only in one variable. Here we take phi of x because it is in two variables. Okay, remember this difference. Now 3 gets cancelled. Phi of x nothing but minus x cube plus c. Now what is our question? To find out stream function means psi. Where is psi? Here is psi. This is our answer. Now we have calculated phi of x. Put this value here in equation number 2. It's 2. Okay, therefore psi becomes this term as it is, and phi of x is this term plus c. Okay, only one method is there. We have one function. We have to find out other function using CR equations only. Okay, why only calculations are nothing, they are very easy. Only we have to take derivatives. Now here is one homework for you. If stream function of electrostatic field is given by, now stream function means this psi is given. Psi is equal to x square minus y square plus x upon x square plus y square. Okay, then find the potential function phi, where f of z is phi plus I psi. Same question, but this time phi is given. You have to find phi. Answer is this. Try this at home. This is homework for you. Okay.